So let me present my research paper delving into a critical issue that affects not only the Kyrgyz Republic, but resonates globally. It is energy pricing design affecting energy poverty, including vulnerable groups. Okay, so here is the content of my presentation. First, let me, the first section I dedicated to energy poverty and an access to affordable, reliable, and sustainable energy in the Kyrgyz Republic. Energy poverty is a condition where individuals or communities lack access to affordable, reliable, and clean energy services, which impacts their well-being, economic opportunity, and quality of life. So here are definitions of energy poverty. In terms of my research, I used the first definition of Boardman from 1991. So he defined energy poverty or energy poor households as that spend more than 10% of their income on basic energy needs. And also there are different approach to energy poverty as a situation where individuals are not able to adequately heat their homes or meet other energy services needs at affordable prices, and inability to secure adequate levels of energy services at home. But in the Kyrgyz Republic, it's so statistics easily allow to assess energy poverty as on expenditures of households on energy services. Here I try to show the problems of access to energy in the Kyrgyz Republic. So even though almost 100% of Kyrgyz people has access to electrical grid, we have only 71% of the population who has stable access to electricity, and it's the indicator is only 62% in rural areas. And also the statistics of sustainable development goals shows that clean fuels account for no more than 20 to 30%, and the indicator is even worse in the rural areas of the Kyrgyz Republic. And we have high so the demand of energy is growing very quickly in Kyrgyz Republic, and domestic energy production relies heavily on hydro energy. So we have different risks influencing energy poverty and energy vulnerability in Kyrgyz Republic. And so here you can see the energy and electricity poverty for different quantiles, from the lowest quantile to the the first quantile is the lowest, the poorest quantile, and the fifth quantile is the highest quantile or richest quantile. Energy poverty is an issue of growing concern in the Kyrgyz Republic, impacting economic, social, and environmental goals. In Kyrgyz Republic, low tariffs, electricity tariffs, keeps a low electricity poverty rate. At the same time, the energy poverty rate is quite high. And however, so 40% of population experience energy poverty, with the lowest quantile exceeding a 68% energy poverty rate, spending over 10% of their income on all forms of energy. So here you can see the comparison of poverty, general poverty rate, energy poverty, and electricity poverty in Kyrgyz Republic. So generally, poor people, we can say that it is the most vulnerable group in Kyrgyzstan, suffering also from energy poverty and from electricity poverty. The other vulnerable groups can include elderly people, children, disabled individuals, and even small entrepreneurs who also suffer from electricity cuts during the last few years. And their energy needs are often higher due to health condition and other factors. Vulnerable groups are disproportionately affected by energy poverty and contributes to a cycle of poverty, ill health, and limited opportunities. So this slide shows that energy pricing in the Kyrgyz Republic, which significantly impacts energy poverty, especially in developing countries with a history of setting prices below the cost of supply. Challenges in energy pricing include ensuring prices reflect true production costs, which can be complicated in countries with weak regulatory frameworks, for example, Kyrgyzstan. And also political and economic factors can distort pricing, leading to inefficiency. You can see here that Kyrgyz Republic has one of the lowest tariffs in the world, and is considerably lower than in neighboring countries in Central Asia, and covering around up to 70% of the cost of electric power utilities. At the same time, transitioning to a sustainable energy requires careful tariff policies, particularly to support vulnerable consumers. To overcome these issues, long-term, transparent, and equitable energy pricing policies should be developed in consultation with various stakeholders, including consumers, producers, and civil society groups. So the second part of my presentation is electricity consumption and expenditures. Because energy pricing shapes consumption habits, particularly among vulnerable groups and lowest quantiles. Here you can see average and total monthly electricity consumption by quantile in 2020, the year that statistics, the last statistics were available in open access. And here you can see that in 2/3 of electricity in the Kyrgyz Republic went to households, driven by low residential prices, resulting in highly seasonal and high consumption patterns. Energy poverty disproportionately impacts these vulnerable groups, perpetuating a cycle of poverty and health challenges. In 2020, tariffs for low consumption were 0.77 Kyrgyz soms per kilowatt hour below the threshold and 2.16 som per kilowatt hour above the threshold. Consumption below the threshold showed consistent monthly patterns, while higher thresholds might influence consumption behavior, especially in winter. Here you can see household expenditure on energy in quantiles 1 and 5. We can see that in the highest quantile, they spend more on electricity and natural gas and district heatings, while the lowest quantiles spend more money on coal. So they use coal for heating purposes, and not only lowest quantile, but also highest quantile, mostly in rural areas, they use coal for heating. So it is also not so good and have health impacts for the population of Kyrgyzstan. Okay. And here you can see that energy expenditure for the lowest and highest quantiles highlights a large winter spending on black coal and electricity for heating and other uses. The highest quantile allocates more expenditure to district heating and natural gas, as I told before. And figure also illustrates that despite higher annual cost spending in the highest quantile compared to the lowest quantile allocates higher percentage of expenditure to energy. It's 41 vice 32% to energy. Regarding electricity consumption, there are minor differences in summer, but more noticeable distinctions in winter. This suggests the highest quantiles relies relatively more on electricity for heating compared to the lowest quantiles. So here you can see that electricity consumption, energy consumption for non-poor and poor people and their expenditures in SOMs also for energy. So the next part of my presentation is electricity tariff policy for residential consumers. Electricity tariffs in the Kyrgyz Republic are set in accordance with the midterm tariff policy for usually for a 5-year period, but it can be changed from time to time. An electricity tariff for end consumers has 14 consumers groups, and and some of them are residential consumers. You can see here it is residential consumers below the threshold of 700 kilowatt hours a month, above threshold, also remote areas, mountainous areas, and they have a threshold of 1,000 kilowatt hours a month during the year, and remote areas above the threshold, and remote areas in general. And so we have also low-income families receiving ÜBİ allowance. So it's people who has 2 and more children under 16 years old, and who do not have a stable income, or their income is very, very low, below some threshold defined by the government. And these low-income families pay 50% for electricity for 50% discount tariff. And this year, so the midterm tariff policy, it envisaged the raising tariffs for inflation rate every year, but it wasn't so, and only this year they raised tariff from 0.77 to 1 Kyrgyz soms for 1 kilowatt hour starting from March this year. And it's also not enough and covering up to 70% of the expenditures or costs of electricity power utilities. And using the model developed by the World Bank, we counted proposed residential tariff design. Here you can see. So we propose a systematic increase in electricity tariff by 0.1 Kyrgyz som per year below the threshold, and by 0.08 above the threshold. It has been calculated that the lower threshold of the electricity tariff for the bottom quintile should be about 260 kilowatt hour per month in summer, and about 400 kilowatt hours per month in winter. So now the threshold of 700 kilowatt hours a month is very high, and it shall be made lower. However, in order to ensure a smooth transition, we propose to maintain the existing threshold in the winter time in the first stage, with a reduction of the threshold in summertime to 400 kilowatt hours per month. In the second stage, we propose to reduce the summer threshold to 200 kilowatt hours and the winter threshold to 400 kilowatt hours. And also, we counted how these tariff increases are expected to have an influence on poverty rate, and electricity tariff hikes have a limited impact on poverty and moderately affect energy poverty. Economic growth is expected to reduce poverty, offsetting tariff impacts. The social protection system can mitigate rising energy and electricity poverty. And tariff increases ranging from 4% to 16% annually by different consumers groups mainly affect wealthier households, providing more support to the poor. Non-residential tariff increases have a modest inflationary effect, expected to remain below 1% overall. So, and here I want to talk about existing and proposed social protection measures. Now we have 3 groups of social protection measures in Kyrgyzstan. The first one is the existing block tariff of 700 kilowatt hour for the very, very low tariff, very cheap. And the second group is discounted tariff for low-income families. As I told before, it's UBK allowance recipients. And the second one is actually subsidies received by the poor, but So the government subsidize electricity power utilities so that they buy coal sometimes they cannot cover their needs to close their obligations on the credits and debts, and government helps them. And we counted that from the 6 billion Kyrgyz soms of subsidies received by the residential categories, only 13% or 0.8 billion Kyrgyz soms are received by the poorest quintile, whereas the biggest beneficiaries are high-income households in quintile 5, who receive 33% of the subsidies, or over 1.98 billion soms. We can say 2 billion soms. And here I wanted to show pros and cons of lifeline tariffs and cash voucher schemes. So while complete elimination of cross-subsidization is unlikely in the short term, reform is needed. This entails gradual changes to the tariff structure coupled with demand-side measures to reduce electricity use for heating. Improved social protection program targeting is also crucial. A lifeline tariff with a summer threshold of 250 kilowatt-hours could replace existing 700 kilowatt-hours block over time. Ultimately, there would be 2 blocks of all consumers. And it should go together with the cash and voucher schemes. You can see I can show it here, pros and cons of cash and voucher schemes. A voucher or cash scheme utilizing existing social protection mechanisms can target low-income and vulnerable households with limited heating options. And they can be used both cash and voucher schemes instead of lifeline tariffs in long-term period, and now they can go together with lifeline tariffs. So the cash voucher schemes could use existing social support systems and better targeted at households in need. And also pros a little spillage of subsidy to households not in need of supports. And voucher schemes can be implemented very quickly, and if funded through cross subsidies, no extra administrative burdens and costs allocated with establishing a levy on electricity consumers and the fund to support the identified households. And next slide, also recommendations. Let me conclude with recommendations. I propose tariff policy revision. As I told before, we have to revise multi-year tariff policy for 2023 and 2025. The first stage and the second stage from 2026 to 2030, supported by cross-subsidy funded voucher or cash schemes for low-income households. And there shall be a gradual reduction of subsidized electricity to mitigate negative reactions. So we can consider intermediate blocks with reductions over time, different in summer and winter periods. In winter periods, it can be higher, so that people could use more cleaner electricity for heat, comparing with the coal and gas. And set tariffs above cost recovery levels for high residential consumption, distribute the burden away from non-residential categories. And we shall work on improving the social protection system targeting to enable direct benefits to the poorest through cash or voucher schemes. Consider phasing out of the lifeline tariff by 2026 if benefits are effectually targeted. And this recommendation aims to strike a balance between reducing subsidies gradually, protecting vulnerable groups, and ensuring the sustainability of the energy sector in the Kyrgyz Republic. And the next set of recommendations is communication campaign to explain that tariffs in Kyrgyzstan are very low by international standards, and also reform of social assistance system, and also once cost recovery level is reached in 2030, we propose to regular tariff adjustments within the multi-year tariff structure. This is all. Thank you very much for your attention.
Thank you very much, Anna. Excellent presentation, excellent research, and very much needed topic. So the audience, for first question, I got a small prize from Tokyo. So please question. Yeah.
Thank you for your presentation. The work you have done is very great. And may I ask a question?
Yes,
How
sure.
how the increase in electricity price was determined?
Mm-hmm.
Yeah, I'd like to. I want to ask a question that how the increase in electricity prices was determined. You said the electricity price was increased, and I want to know the increase was how is the increase determined?
Mm-hmm. Okay, so you want to ask the electricity price that was raised in May this year, how it was determined? Why they raised from 70 cents to 1 som, or the proposed increase that I explained?
I think in the past, right? In the past.
Mm-hmm. Okay, thank you for your question. So actually in Kyrgyzstan, it is like administrative measures. So last year I was working with the World Bank. We prepared calculations and show the tariffs that should be, but actually it was president who told that the tariff should be 1 som, and that's all. It wasn't supported by any calculations. It's just so that to make a nice figure, instead of 77 things, they made it 1 som, and that's all. Unfortunately, it's like that.
Yeah. Sorry, I'll explain. She said 77, it's like cents, like teen, it's coins,
Yes.
77.
Yes.
So it was
Yes.
before 0.77 som local currency. Now it's 1.0 som. Yeah. So
Yes.
before it was like 77 cent, became $1. So because the number was small, and then they just took round number, $1.
Yes.
Yeah, but 1 som is how much in dollars?
Yes.
Quarter?
It's
like
so it's
$0.011
US dollars, one som.
Yeah, still.
So now the tariff is
Crazy cheap.
$0.011 US dollars. So 1.1 US cents, and
Very low.
before. Yeah.
Thank you, Anna.
It
Another
was
question?
even 0.9 US cents.
And thank you very much, Anna. And I have 2 questions. And I don't remember the exact page of your slides, but I remember you mentioned 2 numbers at the beginning, and one number is like 1.6%, and another one is about 40%. And you mentioned that the overall average consumption energy poverty in the country is 1.6%, but the number of people suffering from the energy poverty actually is 40%. So may I ask why the 2 numbers are so, the gap is so large? Why the 2 numbers are so large? And another question is that you mentioned about the tariff design. So do you think is it possible that the tariff is designed differently for the poor people and the rich people? And maybe is it possible that the tariff is a little bit higher for the rich people and is a little bit lower for the poor people? Thank you.
Thank you. Let me just write so that I will not forget the second question. So the first question is, so electricity poverty rate is 1.68%, let's say 1.7%. Because the electricity tariffs are very low, so the electricity poverty rate is also low. So actually, it means that not so many people spend more than 10% of their income to cover the electricity costs. But the energy poverty rate is 40% in average in country, because in winter we have actually quite a cold winter, and people need to use gas and coal to heat their homes. And as we import gas and maybe half of the coal, so it's quite expensive, and gas and coal, and people need to the expenditures for gas and coal are quite high. So there's very many people spend more than 10% for heating for coal and gas. That's why such a difference between electricity poverty rate and energy poverty rate. But also, when we define poverty rate as expenditures not more than 10% of all the total expenditures. But if we look at energy poverty and electricity poverty from different angle, so from different definitions, there will be different figures, because many people suffer from electricity cuts here, and also small businesses, small entrepreneurs, they also suffer from unstable access to electricity. And in winter or in rural areas, some areas they have maybe half of the day they have electricity and half of the day they don't have. So if we look at other definitions, the figures will be much higher at electricity poverty. And now in Kyrgyzstan, UNDP is working on the energy vulnerability issues under the National Human Development Report, and they will make household survey, and I expect that by the end of this year we will have some more figures on energy poverty from the angle of electricity access, reliable electricity access. And on the tariff design, we considered different schemes of tariff design, and actually it's quite different to divide people for rich and not rich or poor. So we have this UBK scheme, but it's only for people who has children, 2 or more children are under 16 years old. But how so many people work from home, for example, and they do not officially register as businessmen. It's good if they pay some taxes, but they cannot also they can not pay, and that is why it's difficult to divide people by rich and poor and to set tariffs for rich and poor groups. And we thought that it will be easier so that difficult for power utilities, because we define people only as electricity consumers, and all of them have the same meters, and only part of Kyrgyz people covered with automatic meters, and the other part are not covered. And we don't know whether the electricity power utilities, they do not know whether they poor or not poor, and we think that it's the government and social assistance ministry who have to help them to cover electricity prices. Yeah, I hope I could explain.
Thank you very much, Anna. Yeah. So we have many questions, but sorry, we will go to next presentation because of time. I hope, Anna, we can talk later, like after this event sometime. Excellent research project, and this is very, very important topic, I think, for ADBI also. Yeah. So actually, I would like to hear your, Anna, opinion about my presentation. So please ask me questions after my presentation. I would want to hear.
Thank you very much. I'm keen.
It's quite similar to your presentation, but the only case is Kazakhstan. So before was Kyrgyz Republic, Kyrgyzstan, now it's Kazakhstan. People might confuse same name. It's different countries, neighboring countries. Okay, so also energy poverty and evidence from Kazakhstan. So same as Anna, I'm passionate about this energy poverty. Yeah, so why I worry so much about energy poverty? Because many countries were asked remove inefficient fossil fuel subsidies. You know, they all criticized like that countries have inefficient fossil fuel subsidies, which mainly like they are not targeted and they cause big burden for government expenditure, so they should be removed. But before, in order to make this decision process, like how to remove subsidies, like Anna said, how to increase prices, we have to understand who will be affected and how will be affected, what portion of population will be affected, right? So similar what Anna said, like we want to know. So this is similar study also about energy poverty. This is energy poverty topic is very important to study in order to promote this removal of fossil fuel subsidies, in order to continue just energy transition. So this is very, very important topic. And especially for countries where energy demand, you know, it's necessary for life, it's essential for life, it's not for convenience, because people need to cook, need heating because it's cold. In my city in winter, like -25 is warm. And it can go -40. So heating energy is not just convenience, and it's necessary for survival. And Kyrgyz also, like some places could be very cold. And if they don't have access to energy, people will get energy by just cutting wood, you know. So it's necessary. People cannot stay without energy. So that's why if energy poverty not considered, we might, you know, by promoting renewable energy, yeah, it's good. But if people start cutting wood, it's actually opposite. So that's not good. Let's okay. So in Kazakhstan, both Kyrgyz Republic and Kazakhstan, we have 100% access of electricity. Yeah, 100% access to electricity we have. So electricity is not an issue, but electricity is too expensive for heating. Okay, so most people will not use electricity for heating. It's too expensive. They need gas or district heating or coal for heating. So electricity is not good enough. Okay, so how to measure energy poverty? Siodan rightly noticed, right? There is a high proportion, like why numbers are so large. When I calculated energy poverty for Kazakhstan, also I thought, wow, my numbers are so large, maybe something wrong. But when I saw Anna got also big numbers, I'm now relaxed. Maybe it's okay. So how to measure energy poverty? There are many measures. There is expenditure. That's what Anna used, 10% of income expenditure. If people use more than 10% of income for energy, then they're energy poor. There are also other measures like self-reported measures, other like multidimensional measures. So the more data you have, of course, the more accurately you will measure. And of course, the more time you have, the more accurately you will measure. The problem that then if you need to calculate fast, then you use simple method like cheap, because it doesn't require lots of data. But if you want to make it accurate and you have data, you have budget for collecting data, then you can make it more accurate. So then we wanted to here compare all these different measures for energy poverty, what we'll see, what numbers we'll get. We're using Kazakhstan, and like Anna said, yeah, there is differences across regions and so on. And we use district heating. I think since most of audience from China, I think in West North China, you also have district heating, right? Right. So you're familiar with district heating, because in Japan, they don't have district heating. So that's not familiar. But in China, you have it, West North country place. Okay, so people have this district heating and also gas. These two things usually used for heating. So we use Kazakhstan data, very recent. We are very lucky. We have data from the National Bureau of Statistics provided up to 2021. This is government collected data survey, government runs it, 12,000 households, and they do it annually. So they collect, they follow strict their methodology. So this is government collect data. We rely on that, and they do interviews like face to face. So we have this on household data, like we go from house to house, collect this information. We ask like, how much do you spend for energy, on gas, and so on. They also ask like, what's your education of household head? Who is household head? Household head is a person who makes decision in your house. So you can think, oh, in my house, who is household head? So most of financial decisions, who makes? You or your spouse? That's who is house, or your parents. So that's his household head. And then we ask like married, not married, where do they live? Of course, urban, rural, number of rooms. Yeah, so all these characteristics. So then the methodology, I think I will not go too deep into methodology to save time. And here results so we compare different methods for collecting, calculating poverty. 10%, this is what Anna used. Then we also use semi-parametric and threshold regression model. We think that the other methods are more sophisticated, would be more accurate. But actually, if you can look at the data results, you can see they're not too far away. Okay, we are different, but still, so energy poverty, my conclusion, energy poverty between 40 to 50% or even 60%, still very, very high. So whichever method you use, energy poverty is very high. So nearly half of population energy poor, imagine. So this is similar what Anna said. She also had very big numbers around 40, 50. So there is some difference between each method. And so we think that other methods probably better, but the key message that we're all showing that nearly half of population energy poor, and I think this is important. So then we looked at results, what characteristics of households who are energy poor. So when household head is female, they are more likely to be energy poor. And also, when they're rural, more likely to be energy poor, and less educated, they're more likely to be energy poor. I think this is very, very intuitive. This is understandable, right? The less educated, they are more poor, rural are more poor, and when female household head, it's more poor. So key findings, key conclusions. So my key takeaways, we compared several methods, all of them showing very high numbers between 40 to 60% of energy poor. So my key takeaway, half of population, nearly half of population are energy poor. So whatever policy will be implemented, like Anna said this, like price increase and so on, population will be very sensitive. Why? Because half of population will be affected because they're energy poor. So I agree with Anna that this policy has to be very, very carefully. Price increase should be done very carefully with calculations, because big share of population energy poor, and also whatever if government will do what Anna suggested, like providing social security, like subsidies and so on. So for budget, it will be budget need to be prepared, because like if half of population energy poor, so that half of population will need to receive all this social security. So that's will be a burden for a budget. But at least this is better than inefficient fossil fuel subsidies, because inefficient fossil fuel subsidies, current one, they are not targeted, they're not efficient. So if government will switch from this not targeted inefficient fossil fuel subsidies to this targeted social security, what Anna suggested, I think that will be better. But of course, this need to be done with care, how to determine who is energy poor and so on. And yeah, so policy recommendations here, that energy poverty varies by region, because, some regions, countries are big, like big countries, they have diverse climate, different energy prices. So energy poverty varies by region, and energy poverty is very high. So official statistics of energy, not energy poverty, income poor. Like Kazakhstan is middle low income country. It's not low income country. It's middle low income country. GDP per capita is quite high, and official income poverty is 5.2% only, 5.2%. But for energy poverty, you see, we calculated nearly half of population. Yeah. So we in terms of methodology, semi-parametric and threshold, we think more accurate than 10% approach. Yeah, that's it. Thank you so much. Okay, any questions? Yeah, please. Thank you. We start from the room first. Okay.
Okay, thanks for your presentation. I have two questions, and the first one, I wondered what's the key difference between the energy pattern between the urban area and the rural area. And the second one is what are the underlying social economic factors that contribute to the energy poverty in Kazakhstan, and how do they vary across different regions in the country? Yes.
Thank you. This is very important question. You are right. Urban-rural difference, I think Anna showed and me. Yeah, we have like striking, very big difference. I actually, yeah, it's good to check this question. Why is that rural like more poor? I think one of the reasons, obviously, quick reasons I can mention that income in rural is lower than in urban, right? And then also energy access. In rural, they don't have much choice of energy access. They usually use coal, and they don't have much infrastructure. They have electricity, yes, and also usually rural electricity is like quality is lower than urban. They might have more blackouts and so on, and they more rely on coal. So they don't have district heating in rural, basically, and they might have gas. So infrastructure, of course, much better in urban. Also income probably higher in urban. So then all the policies, I think, need to be especially carefully for rural, right? Because they are more energy poor, you're right. And for regions, so regions, they have different prices, energy prices, different across regions. And also income, unemployment, very different across regions. That could be why there is energy poverty is different, and energy access also different. So the Kazakhstan is huge country, enormous, right? It's smaller than China, but it's 9th largest country. So for infrastructure, let's say gas pipeline, it's quite hard to give access to everyone to gas. Even Kazakhstan is gas-rich country. We don't have gas access everywhere because, you know, for these large distances, you need pipes. So not everyone goes gas access, which is gas is very cheap for heating, right? And then not everyone has access to district heating. So each region has different infrastructure limitations. Yeah, so some has gas, some doesn't have gas. Yeah, like that. But everyone got electricity, and some regions electricity cheaper, could be lower, more expensive, and coal also could be different price. Yeah, I think this regional what you raised very important. Okay, we have raised hand from Hi, please.
Thank you so much, Dina. For the very interesting presentation. So when I see your presentation, I feel so surprising because like we have like 100% accessibility to electricity, but I think the same reason, like even it's like accessibility like 100%, but affordability also is a problem. So actually you also address it in Kazakhstan case. So really great thing. So I have some comments. So in the papers, you use income level, so household income per capita. So I'm a bit confused. I'm a bit worried that maybe the income may be correlated with other control variable in the models. For example, like the income maybe affects the education. Educational level. So also the household total income per capita maybe affect the living space as well. So I just worry a bit about like the endogenity's problem in these models.
Yeah,
another question is that when you mentioned about the approach, so I curious, like maybe the multi-dimensional approach, as you mentioned, maybe also really interesting. So if you can like address the multi-dimension like cooking, lighting or something, so maybe also interesting. Yeah, because it's like different perspective of energy poverty. Yeah, thank you so much. Yeah.
Thank you. Hi. Yeah, excellent question. So about indigeneity, yeah, probably we need IV. I don't see in slides IV, so maybe we didn't use. So probably, yeah, you're right, need IV. And for multidimensional, yeah, it's like we calculate like index. So we don't do it here, like calculating index for multidimensional. Yeah, so we use econometric methods. Yeah.
Oh.
Yeah. Yeah, but you're right. Yeah, it's better to compare all of them. Yeah, it's interesting. Yeah. If time allows, can do it. Yeah. Thank you very much. Hi. Thank you.
Yes, thank you.
Yeah. Anna, do you have any comments from you?
Yes. Thank you very much for the perfect and very interesting presentation. I have also 2 comments or questions. The first one, I wanted to hear your opinion about energy poverty and energy transition. Have you considered how the renewable energy penetration in Kazakhstan influences energy poverty? So from the one hand, it is makes electricity more makes more access to electricity. From the other hand, it influences the level of tariffs. It makes it higher. What's your opinion? And my second question, maybe I don't know. Which indicators of energy poverty on energy access do you use in multidimensional poverty index in Kazakhstan, if you know?
Thank you very much, Anna. Yeah, very good question about energy transition, like just energy transition. So far, the price increase in Kazakhstan not related, in my opinion, to energy transition. The price increase happening because of the, before it was like heavily subsidized. So what electricity price was, people just paid at marginal cost or maybe below marginal cost, maybe like just labor cost, right? So all the infrastructure was worn out without replacement, without fixing it. So that reduced the quality of electricity, of energy supply, because the equipment worning out, there is no like budget to fix it because prices are so low. So this kind of subsidy called off budget, or called also implicit subsidy. When funding, there is no expenditure counted. It's just that if price is not full, price is like below marginal cost or at marginal cost, they basically cover like the labor cost just to pay salaries, but not to fix equipment properly, not to replace equipment. They don't cover amortization. So all the fixing was like at low cost. They couldn't afford to fix it properly. So quality of infrastructure was falling, and that's why could be, more accidents on infrastructure. The supply of energy is not so good. And then so of course they need to increase price in order to maintain this infrastructure, in order to continue to supply energy. Like it's also water, sewage, all this infrastructure, it was built during Soviet time. It's very old, so it's already nearly like how many, nearly 30 years since Soviet Union gone. And then so it's lots of infrastructure need to be replaced or fixed, and the funding, of course, public expenditure really constrained. The COVID happened, then war happened, so all this public expenditure really limited. So the only option to increase energy price need to increase. So the country started to increase energy prices slowly, but it's not because of energy transition. It's not related to, it's not related to going green. It's because of in order to maintain infrastructure prices growing. Yeah. I hope I answer. And then for multidimensional approach, we didn't calculate it. So I just put it in literature review that what people do. So that's what included. Some people do is multidimensional also. Yeah. I hope I answered your question.
Thank you very much.
Thank you, Anna. So, okay, let's move to the next paper by my colleague, Hai. He will present our paper on carbon pricing.
Thank you so much, Dina. Thank you so. Can you see my screen?
Yes.
Okay, thank you so much. So thank you so much, everyone. So it's my great pleasure to present in this event. So this is the paper I co-written with Dina. So the title is Carbon Pricing and Firm GHG Emission, Firm Level Empirical Evidence from East Asia. So without further ado, I would like to start my talk. So here is the structure of the presentation. First, I would like to give a brief introduction, the research data and variable definition. The next is about research methodology, empirical finding, robotic check, and finally conclusion and policy recommendation. So first, I would like to talk about like what is the carbon pricing. So carbon pricing actually refers to the policy tool construct to account for the cost of externality associated with GHG emission. We are typically borne by the public in the form of healthcare cost from drought and heat wave, cost damage, property damage from flooding and rising sea level. So what this policy does, this policy actually aims to associate the cost with their source by imposing a price on the carbon dioxide CO2 emissions generated, thereby holding emitters accountable for the cost of their action. So the importance of the carbon pricing in reducing the emission in order to prevent catastrophic climate change has been highlighted in the literature as the most efficient tool to reach the global emission reduction targets. The optimization of emission trading as a vital strategy to implement a carbon pricing has progressively emerged as a crucial driver in supporting the global transition towards the low carbon energy sources and supporting the economic transformation aiming at reducing carbon emission. So the European Emission Trading or EU ETS is the world's first emission trading system, has been a key element of the European Union climate change policy since it was set up in 2005. And since then, there are 47 national and 36 subnational carbon pricing policies has been implemented as a carbon tax or emission trading scheme or ETS for GHG emission. So across the since then across the Asian Pacific region, a number of countries has adopted the carbon pricing as a means to promote a low carbon transformation. Notable examples of the countries that have already implemented carbon pricing schemes, including Japan, the People's Republic of China, the Republic of Korea, Kazakhstan, New Zealand, and Singapore. And recently, Indonesia has joined this group of nations in 2022, if I remember correctly. So, however, the implementation of the carbon pricing encounter substantial resistance in numerous countries, especially in developing Asia, owing to the inherent obstacle associated with its practical execution. So here is the carbon, here's the finger which presents the carbon price in selected country and region in Asia as of May 2023. And you can see that Japan and Singapore and Kazakhstan has implemented relatively low carbon price, whereas the Republic of Korea and China have adopted higher carbon price. Although Japan carbon tax has contributed to a partial reduction of approximately 10% in emissions since 2004, a higher price is also required to effectively achieve Japan's ambitious national target of a 26% reduction in GHG emission by 2030. 2030 as officially declared in 2021. Lin and Jia in 2019 also indicated that setting a carbon price ranging from $10 to $20 represents the optimal cost of action for the implementation of the China national ETS. So despite significant attention to the carbon pricing, a few handful of empirical studies examine how the carbon pricing has affected emission, and most of them focus on Europe. According to the study by Green 2021, the empirical literature examining the effect of the carbon pricing on emissions in Asia is highly limited as well, and mainly focus on Japan. However, the results are controversial following the study by Arimura and Abe in 2021. And furthermore, the existing empirical literature investigating the impact of the carbon pricing on emission using the country level data. However, rely on the country level data can obscure the substantial difference and variation among individual firms. This heterogeneity can play a key role in determining the effective of carbon pricing policy. So therefore, in this paper, we try to investigate the impact of carbon pricing on enterprise emission using the firm level data. So here is the research data and the source we use in this paper. So to investigate the impact of carbon pricing on firm emission, we construct the unique panel data set of firms that provide emission between 2010 and 2021. And the emission data is collected from the environmental package of the S&P Capital IQ Pro. And the information on the carbon pricing is obtained from the carbon pricing dashboard of the World Bank. We then match this two information with the firm level data collected from the S&P Capital IQ Pro, considering the availability of the key firm level related variables. And eventually we end up with a sample of 2,445 firms from Japan, more than 1,100 firms from Republic of Korea, and 4,207 firms from the People's Republic of China. So here we present the variable definition. So the main dependent variable we use is the absolute GSC, which is calculated the natural logarithm of absolute GSC emission. Also, we use two different ways to calculate the absolute GSC emission. We use direct emission and also direct and indirect emission. Another key dependent variable in this study we use is the GSC emission intensity, which is natural logarithm of the GSC emission relative to total to the firm revenue. And as we mentioned above, the main independent variable is the carbon pricing. Here we use the two proxies for that. The first one is the binary, which equal to 1 if the carbon pricing is implemented in a country and 0 otherwise. And the second proxy is the carbon price rate implemented the carbon price initiative. This one, both information we obtain from the World Bank. And next is the IVs. We use the country level carbon dioxide emission relativity to ZDB as the IV. And for control variable, we use the firm size, proxy by the natural log of the total assets, the financial leverage calculated by the total liability divided by total asset, and the firm experience proxy by the years since the firm incorporation, and finally the firm profitability, which is return on total asset. So here is the research methodology. So we to investigate the impact of the carbon pricing on firm emission. So we estimate the following model using the fixed effect. We also incorporate the two individual fixed effect and time fixed effect to account for endogeneity that may occur in the model. And as I mentioned before, in this study, we use both absolute GHG emission and also GHG emission intensity. And to check the robustness of our finding, we also examine the impact of carbon pricing on firm emission when both direct and indirect emission are taken into consideration. To further account for endogeneity, we use a two-stage least square by using the country level of carbon emission as an IV for this one. So we also use several robustness check to check our model, and also we relax the consumption of the conventional assumption of the IV by using the plausible isogenious framework. So this is the main result of our paper. So the first two columns is a result using the direct emission, direct absolute GHG emission, and the next three columns using the direct and indirect emission. And basically we obtain, we can see that the carbon pricing policy have negative and statistically significant impact on the country, on the firm absolute emission. And for both Japan and Republic of Korea specifically, we've observed sizable effect of about 49% and 60% of reduction in firm emission in Japan and Korea. This result indicates that the carbon pricing policy actually in Japan and Korea actually incentivize the GHG emission reduction. However, the GHG reduction could have been as a cost of the production. Therefore, we also investigate from the emission intensity later, which will be so later in this in my talk. So, however, the estimated of the carbon pricing in the People's Republic of China is not significant. This could be due to our data limitation, because in our sample we contain only 1 year of effect of the carbon pricing, because the government of the China implemented the national carbon pricing in 2021. So therefore, the impact of the policy might be not captured by this econometric analysis, or maybe we have to wait until a few years to get back into this question for China when the data coming up. So as we mentioned, maybe reducing the absolute GHG emission maybe at the cost of production, because big firm normally emit more. So that's why we also present the result using the GHG emission. And similarly, we also obtain the negative and statistical impact of the carbon pricing on firm emission for both Japan and Korea. And similarly, there's no statistically impact on emission on firm emission in China. So we also present the result across sector, and here is the main result. The energy and utility sectors experience the most significant reduction in GHG emission intensity at a share in firm revenue in response to the carbon pricing compared to the other sector in Japan, Korea, and also China. Actually, this result is not surprising because these sectors are highly one of the most emitting sector with available substitute to fossil fuel. For example, like renewable energy. Therefore, the policy maker in the country in general often consider them as the targeting sector when they design the carbon pricing. Among the three countries, Japan policy demonstrates significant impact across all considered sector. Similar results are obtained for Korea. We also obtain significant impact across all sectors except financial. In contrast, the BCR policy have significant impact only in two sectors, energy and utility. This result is unsurprising given the coverage of national carbon pricing is substantial in Japan. It's 75%, and in Korea is 73%, with many sectors cover, while in People's Republic of China, national carbon pricing have smaller coverage of around 33%, with many focused on the power sector cover. So we also present the result for subnational carbon pricing. Specifically, we are using the subnational carbon pricing in Japan, like in Tokyo CAP and Saitama ETS, and 7 province level carbon pricing in BCR, specifically like Beijing pilot, Chongqing pilot, Fujian pilot ETS, Guangdong pilot, Hubei pilot, and Shanghai and Tianjin. And the result, the key result we find is that both subnational carbon pricing in Japan significantly reduce GHG emission intensity and absolute emission of the firm in Saitama and Tokyo Prefecture. The impact of BCR subnational carbon pricing are, however, mixed, while Japan, Hubei, and Tianjin experience significant decrease in firm GHG emission due to subnational policy. However, we find no evidence on the impact of subnational policy on firm emission in the remaining 4 provinces. So the potential explanation for the insignificant impact of the subnational policy in China is that they were implemented as a pilot policy before implemented the national, just their coverage could be smaller. However, unlike the country carbon pricing policy, we could not run the estimate across sector for each subnational policy due to small number of observations. And we also have obtained similar result for the IV regression that we've obtained negative and significant impact of the carbon pricing for both Japan and Korea, which is consistent with the fixed effect result. And the magnitude of the effect for Japan under the IVs are slightly larger than those under fixed effect regression. And the result for BCR are not totally consistent. The results are consistent with direct emission, but not consistent with indirect and direct and indirect emission. The fixed effect results show significant impact of the carbon pricing in BCR. However, under the IV regression, we found mixed result for BCR with regard to the impact of the carbon pricing on firm GHG emission intensity, and the not consistent effect of the carbon pricing policy for the for PCR might be BRC might because of our data limitation, as indicated in the previous section. The carbon pricing policy were implemented in the BRC in 2021. Just we only have 1 year, like 2021, in which the carbon pricing dummy equal to 1 in our data. So for Roboni check, we use a carbon price instead of the carbon dummy. So similarly, we also obtain the significant impact and negative for Japan and Korea. And here we do not have the result for China because we do not have the carbon price for China. That's why we cannot have the result here for China. And we also in the traditional IV, we assume that no impact, no direct impact of the IV on the firm GHG emission. So this assumption is really tricky. So in this exercise, we allow the country level carbon or the IV have direct effect on the firm GHG emission. And you can see that the estimated result here is inside is negative and inside the 95% of confidence interval, which means that our result is robust to this exercise. Even we allow for direct emission, direct effect of the IV on the GHG emission for both carbon price dummy or the carbon price rate. And we similar here. So for conclusion, so here is the conclusion in our paper. So first, we find that national carbon pricing significantly reduced both GHG emission and GHG emission intensity of the firms in Japan and Republic of Korea. Second, the subnational carbon pricing policy decreased firm GHG emission in two provinces of Japan, which is Saitama and Tokyo. Third, energy and utility sector experienced a substantial decrease in GHG emission intensity as a result of the carbon pricing policy. And finally, our main result for Japan and Korea are robust to different model specification and various measures of firms GHG emission. And for policy recommendation, so we have we success that policy from other developing Asia that have not implemented carbon pricing policy can consider both national and subnational carbon pricing policy to significantly reduce the GHG emission and, more importantly, GHG emission intensity, and to further reduce GHG emission, for example, to meet the net zero carbon emission, greater carbon price can be more effective. However, this needs to be done with care, as greater carbon price can also decrease production. For limitations, this paper have several limitations, mainly because of data availability. So that's all for my presentation. Thank you so much. And I hope you enjoy, and we welcome all comment and suggestions to improve, for us to improve our paper. Thank you.
Thank you very much, Hai. So we have actually, we are lucky we have audience from China. So they are very great experts on carbon pricing. Please.
Yeah.
Okay. Hello, can you hear me? And
Yeah.
I have two questions, and the first one, I wondered how do the specific design feature of the carbon pricing mechanism in the East Asia the country contribute to their effectiveness in reducing the greenhouse gas emission? And the first one, what are the key challenge and the barriers encountered during the design and the implementation of the carbon pricing mechanism in the East Asian country, and how do these challenges can be adjusted to facilitate the adoption of effective carbon pricing strategy in other countries? And that's all.
Oh, can you? I couldn't hear it clearly. Can you make it like short or clear? I couldn't understand.
Oh, okay. The first one, how do the specific design feature of the carbon pricing mechanism in the East Asia contribute to the effectiveness in reducing the greenhouse gas emission? Yes. Hello? Yes, hello? Can you hear me? Can you hear what I said? And
I just heard, not very clear, but I heard something about like carbon pricing mechanism or something like that.
Yes.
Oh, so for the effective, I think like as we can see the significant result for Japan and Korea, because like the coverage of the carbon pricing for the country is like more than 70%. So I think in order to have like effective result of the carbon pricing on emission, I think the country should expand the coverage of the carbon pricing, like not only in the industry sector, maybe in other sector, like the consumer sector, like or financial sector as well. So in order to reduce further the emission for in the whole country. So so
okay.
do you have further comments or other question?
And what are the can this carbon pricing mechanism that be implemented to other countries? Yes.
Oh, and I think so, but I think because in this paper we use East Asia data, so especially for China, so we find some bovine in China actually effective in our model. So this framework can be actually from our point of view can be extended to other developing Asia as well, because for Japan and Korea it's more developed, but we found significant result for subnational carbon pricing in some province in China. So I think if we can look further for the coverage of the carbon pricing is like subnational province, because like at the province level, like the province scale in China actually is really large. It can be like separate countries in scale for the others. So I think the coverage for can be like, I mean, this effective can be applied to other countries in a developing country in Asia as well.
Okay, thanks for your answer. Yes.
Yeah, thank you so much.
Thank you for sharing. I got one question for this topic.
Oh.
So I want to ask about the statistical data you have collected to do this presentation. How many provinces have you like investigated in China for this data you collected?
Okay. So for regarding this data, so we collected almost all firm in China, which means that we, as long as they have the emission data, because the emission data is quite limited. So if the firm have emission data, we collect them all, and we include all of the firm into our model. So which means that we do not limit it to specific province. So in our data, we have I don't remember correct, but we have more firm all over China, more than 30, maybe 32 province.
22. Oh, okay, that's quite a large scale of data.
Yeah,
I think. Yeah.
yeah,
Thank
yeah.
you.
Yeah, thank you so much. Yeah.
Okay, thank you so much for all questions. Let's move to next presentation. Unfortunately, due to some circumstances, two speakers couldn't join, and they send their apologies. So we're going to our final presentation by Anne, who is from Goethe University of Frankfurt, Germany, and he'll present transition risk uncertainty and robust optimal monetary policy.
Yeah, thank you. Let me share my screen first. Can you see it well? Yes,
Perfect.
no? Okay. So I should start now, I guess. So thank you, organizer, for including our paper into the program. So this paper is a bit different compared to all the paper inside the program, but I'm excited to be here today. So the talk today is about, at least the title is about transition risk uncertainty and robust optimal monetary policy. And this is the joint work with Alexander Duke, also from Goethe University, Frankfurt. So let me get into it. So why we start with this project? So we know that climate change has become one of the most prominent concerns globally in the last 20 years. And then people talking a lot, at least in Paris Agreement, about cutting off the greenhouse gas emission. Among many other international organizations, the IMF points out that greenhouse gas emissions should be reduced by 40% to keep the increase in global temperature below 2% or 1.5 degrees Celsius. And also on the table, many countries are talking about to achieve zero net emission economy by 2050, at least for developed country. And for emerging market and developing countries, it should be around 2060. And then according to, also there are many great paper in this section talking about using carbon policy or carbon price to reduce greenhouse gas emission in general and other emission. So the question of our paper is that what is the economic cost to achieve environmental targets to carbon price policy? And we try to emphasize this is ambitious environmental target. And how much there is differ between model to model, because central bank usually use DHE model and other macroeconomic models to do policy. And second question is that how should the central bank conduct its optimal policy during this transition risk, and during this transition using the carbon price to achieve environmental targets. So let me give you some preview of our result. So we try to document transition risk uncertainty in terms of different in prediction in our set of model, and we talk about it more later. So we try to focus on two scenarios. First, the minus 40% of emission, and we document the output loss in between 0.7% to 4%. We do document some deflationary effect, but most of the model predicts inflationary, which is inflation rank between 0.5 to 1.5 percentage points. So this is in line with what we call green inflation. And in the case that we want to cut off 100% emission by 2050, we observe the output loss between 2% to 6% and no inflationary effect. So inflation is ranging between minus 0.5 to minus 0.1 percentage point. In our scenario, we also, in our scenario analysis, we also do some analysis, and we find that pre-announcement effect, pre-announcement of carbon price affect the volatility inflation and keep the rest of the economy, or at least macroeconomic environment, basically the same. I will show you the result later, so hold there. So we move on to the question like what central bank can react under this scenario. So we find that taking into account model uncertainty means that taking into account other model prediction, central bank should react less to inflation due to model uncertainty. And also we find that they are more cautious during the transition, which means during the path that we use carbon price to achieve environmental targets. We also propose a method or way to determine the optimal carbon price or carbon price reaction, and we call it in cooperation with the government. And in this case, central bank react less to inflation and more to output growth. Our model robust rule has among many other some advantage. So we achieve like 4 to 20% higher central bank loss compared to like the most efficient model specific rule. But we behave much better when we put the wrong central bank rule into a model, which means we improve 11 to 20% more efficient compared to the wrong rule. We talk about it later. So how did we do it? So we include environmental aspect, including emission, pollution, carbon price, and abatement cost. In 29, work hard and new consistent DHE model. We try to cover most of the prominent outbreaking in the fields, such as nominal rigidity, weight rigidity, financial friction, shared and matching, also some small open economy and two-country model. And then we implement the carbon price in 3-2-0 model to achieve two targets. First is that immediately cut 40% emission and zero net emission economy by 2050. And then we also simulate the case that we pre-announcement of carbon price part for immediately cut of 40% emission in 1 year. Also, during the optimal robust exercise, we conduct the optimal robust monetary exercise through 3 scenarios. So over business cycle, which has been taken into account on the shock in the model. Given that we have like enriched environmental aspect, and during transition risk mean that we only conduct optimal policy, especially for transition part. And then in cooperation with government, we mean that we do determine at the same time the optimal response of carbon price or carbon tax. And the optimal monetary policy. And then we document the disadvantage or advantage of using model robust rule. So I will talk briefly about literature. So this work relate to arbitrary strength of literature. So we rely on the strength of like climate model from the first work from Harter 2012. And then we also rely on the fast-growing literature on transition risk. Many other include one other paper of myself in 2023. And then because we use model uncertainty, so we rely on the strength of literature of using model uncertainty to determine robust monetary policy. So we try, this is the first overview of how we implement the environmental aspect. So output will produce good, and then this come with emission. So firm have to pay abatement costs to clean out part of the emission. The level of emission will be taxed by emission tax or carbon price, depending on the language. The rest of the emission that have not been cleaned by the abatement technology will accumulate to become pollution or emission stock, and this cause some damage to productivity level of the production sector, and then this go on and go and this continue. So here I show you but anyway, so this is anticipate carbon price to cut emission by 40% in 1 year. So it's happened in the fifth quarter. So this is a quarterly model. And then in the first 4 quarters, nothing happened. So the economy stay in the steady state. You can see that here. And then the blue line is the means response of 29 model, and the dark black line is response of the seminal work, the seminal model of Smith and Guter 2007. So we do see that the mean prediction is the output loss is around 2% at the bottom. Investment drop significantly more to consumption, which is well documented in the literature. Like I briefly talk about in the beginning, we have in average inflationary effect. So we do document some green inflation, and interest rate more or less react to inflation, inflationary effect. So the natural question is that because we implement carbon price, you can think like overnight carbon policy, like you sleep today and then you wake up tomorrow and carbon price is there already, which is unrealistic in real life. So in this slide, we try to answer this question. So in the rest, so the blue line the same in the previous slide, but the red light is that we say that we announce carbon price will happen in the fifth period from the period zero, so 1 year ahead, 1 year ago. So we see that because the household anticipate the implementation of carbon price, they start react ahead, so they drop the demand. So so we get into recession much sooner. However, I want to point your attention to the inflation. So because the household side drop the demand more compared to the supply side when the carbon price have not been yet active. We do observe some deflationary effect in the first 4 periods, and only when carbon price take into account, now firms have to produce with higher costs, and then they reduce their production. Now we do have inflationary effect. And then we think about like should we wait 1 more year to implement the carbon price, or we want to do it now? So in this case, I try to simulate the linear increase carbon price to reach minus 40% cut of emission by also fifth quarter. So we can see here the emission decrease continuously from P0. And in this, we observe more or less the same macroeconomic environment, but we don't observe any deflationary effect. And the peak of inflation is more or less the same in the previous scenario, which means that interest rate do react less and less volatility also, less volatility in inflation, less volatility in interest rate, and central bank seem benefit from this. And lastly, I show you like how we simulate the scenario that we reach the zero net emission by 2050. So like we say that 120 water from here. So we reach the minus 100% emission cut by 100 by the period 120. And the house only fully anticipate of the carbon price increasing. And then the output loss is around, on average, 3.5%. And we do not observe any inflationary effect during this transition part. So move on to the second part. So how we determine optimal model robust monetary policy rule. So we try to determine the parameter inside the policy rule through minimize the variance of minimize the central bank loss function, which is the weighted average of variance of inflation, variance of output growth, and the penalty of changing the policy rate, which is variance of interest rate. And by that we we find the optimal of rho alpha pi and alpha y, which is the reaction to inflation inside the policy rate, inside the policy rule, to annualize inflation and to output growth. So we do it like over business cycle and during transition risk with the permanent carbon price implementation. And then during the cooperation case, we try to determine the reaction, optimal reaction of carbon price or carbon tax to emission, we see the ET here. And to do it, we need to bring into the central bank, not central bank, but cooperation loss function, also the variance of emission, and the penalty of changing the tax or price. And we do it through only a positive TFP shock, because positive TFP shock gonna push up the production and then hence push up the emission as well. So there are many results here, but I want to give you some takeaway. So with model uncertainty, mean taking every model into account, like try to minimize the choice central bank loss function. We do see that more cautious to central bank to react, which is over business cycle, which is react less to individual model average. And only in the case of corporation, the reaction to output growth is much stronger, which is the value of 16 here, compared to normally central bank would react more to inflation, which is quite standard in this literature. And during transition risk or transition path, they're slightly more cautious for central bank to do it. In this part, I try to plot the reaction of our set of model using the optimal parameter that we have conducted in the previous slide. So blue line is using the optimal parameter of that model, and the red like we do the optimal parameter that using choice set, like weighted average of each of every model central bank loss function. And the black line mean that I use the wrong rule. So I use one rule of one specific model to all model, which is I call this the wrong rule. So taking into account model uncertainty, we do see the advantage are larger than disadvantage. We both see that our model robust rule is more or less comparable to like the optimal rule of the model itself. So what I mean model specific rule. So model specific rule is that we optimal each model by itself and then sum the loss the average loss function. For model robust rule, we sum the loss function and directly conduct optimal monetary policy to minimize destroy the robust rule. A model specific rule in other model that we plug one model specific rule to all other model and then just take average of every model. So we particularly take a wrong rule for every model. And here also we document some advantage of using model robust rule. So on average, we do see that model robust rule, of course, work less effective compared to the old model rule, but then much more effective compared to using the wrong rule. So for concluding remark, in this paper, we try to implement environmental aspect to carry out 29 DHE model. And we see that 40% cut of emission costs 0.7% to 4% output loss. Also, central banks should react less to inflation due to model uncertainty. And and we find that central bank should be more restrained during the transition. For policy implication, we do find that the carbon policy can be used to reduce emission and achieve environmental target with the cost, with the economic cost. And we do find that the government should act now rather than waiting. Also, in our analysis, we see that a good communication and carbon price agenda can reduce volatility significantly, especially in inflation. So we do recommend it. Given that the uncertainty in the economic cost of carbon pricing is quite large, so 0.7% to 4%. We do recommend policymakers, especially central bank, to take into account model uncertainty when decide optimal policy. So that's everything from my side. So thank you so much, and comments highly welcome.
Many thanks, Anne, for your presentation about the impact of carbon pricing on monetary policy. So I would like to invite questions, please.
Thank you very much for your interesting presentation. And I have two questions about your proposed methodologies. So I think the key of your research, this research, is about the robust, right? So the first question is about how can you guarantee your proposed model is robust? And the second question is that I want to ask about what's the key factors to a robust methodology.
Sorry, I can hear very well the second question. Can you repeat?
Yeah, I want to ask, for example, so if anybody else want to design a robust model, so what kind of factors or what kind of key factors they can consider for designing a robust model? So can you give some like clues for designing a robust model? Yeah.
Yeah, thank you so much for the question. So the first question, I must say you like the language inside literature. What I mean, robust rule. Robust rule mean that, so imagine that you don't know which model is right. So you have a set of model, and then you don't know which model is best fit for your economy. So the model robust rule is that I can show you here. Technically, you have a loss function, so central bank target of each model, and you take the average of all the model, and then you surely minimize this joint rule among model. So in simple language, you take into account of the loss function in all the model inside the set of choice rather than each model loss function. So that's what we call model uncertainties, or at least what the literatures see. The second question is that for the second question, so what we find here is that that using a losses on so many work hard DHE model is that a prediction model is very wisely. That means that we should consider a lot more model when we determine our monetary policy or optimal policy in general. Of course, that every central bank, they do have their own model, and then the model is well estimated for their own country. But at least here also, some central bank, they do have many different models to compare the results. So I think that's one approach that they are taking into account.
Yeah, thank you very much.
See
Hi, please, yeah.
your raising hand.
Yeah, hi, please.
Hello, Anh. So thank you so much for the presentation. I was so interested in the monetary economics. So actually, since I have some couple of questions. So the first one is like you incorporate the environmental aspect into the 29th New Keynesian model. So actually, the simple question is why you consider the 29 model. Of course, I see some famous model like Sweat and in 2007, I think a very famous one, but the first one is like Y29, and the second one because you incorporate like environmental aspect into the model. So I asked which method you use to have the parameter. For example, like did you use the calibration techniques or Bayesian estimation to have the environmental parameter? Yeah, and yeah, maybe I also consider like if you incorporate the the third one is that if you how can I say when you incorporate the environmental aspect, I also exciting to see if it affects the welfare of the household or something. Yeah, so yeah, thank you so much.
Yeah, thank you so much for your question. So first question, why 29 is not a magic number, but actually the most model where we can incorporate, given we want to incorporate more, but then we have problem in also time constraint, and then the the complex of the model. So that's the most number, the biggest number that we have so far. Of course, we try to get as many models as possible, as you can see in the paper. And then the second question should be can you remind me? It's about calibration or?
I just curious because when you incorporate the environmental aspect, there also new parameter, right? So how you have like you use calibration or matching moment or Bayesian estimation for the new set of parameter?
That's a good question, and should be done in the future, but it's cumbersome given that we have like 29 models or so. So some model in our analysis is calibrated or estimated for the US and the Europe. I think we have somewhere. Yeah, so we do have some model for the US. So in here, and then three model for Euro area. For the set of parameter that relate to like environmental or something, we take it from Hotel 2020, just recently estimated, just to make sure that we have the same calibration, at least in terms of environmental aspect for all the model. And we try to keep the calibration or estimation, of course, parameter for each model by itself to get it here. So it's for sure the better approach should be re-estimate or recalibrate, but that may be too much for the last set of model.
Yeah, that's why I'm curious. Why I asked, because I see 29 model. I think it's like, for example, like Smith and Water in 2007 is the famous paper. I think they use Bayesian technique. If you estimate one model, it takes like a couple of hours for one result.
Yes.
So if you have, but I asked why 29, because you incorporate maybe quite famous model, but there one big a really big guy in the field like Gali. I think if you ask one model, I mean, from Gali, I just forgot, Gali and Monasali, they're really big. That two is very big, big name in the field, Gali and Monasali. So if you can have one model from them, so that would be great. Yeah.
Yeah,
So
yeah. Thank you for that. Yeah. Go on, please. Sorry.
So just to be confirmed, so for environmental parameter, you just borrow from the literature, estimate or calibration, right?
Yeah. So there's the recent literature, I think by should be I have it somewhere. So it should be either like we take it partly from hotel, and then the recent update version of that are not like the other version. They recently estimated it should be hotel 2020. So we try to use the calibration for all the model and keep it at the same.
Oh, okay. I see.
So for like try to make comparison make sense a little bit.
Yeah.
And the rest of like macroeconomic parameter, I try to keep the model calibration with the estimation, which already estimated for either US or the Euro area. Inside the paper, we also distinguish between two areas, given that most of the model is calibrated or estimated for either the US or the Euro area.
Yeah.
So we do also separate it out to see.
Oh, I see. So yeah, so I don't know, but 29 model is quite big number, and maybe the model is quite different from each other. So if one paper they just use calibration, and the other they use Bayesian estimation. So for me, it's really difficult to compare between the like 29 model. So because like the structure is totally different. So is all models in here using the open economy or closed economy, all model? So
I believe most of the model is closed economy.
Okay,
actually.
I see. Okay.
And
So
some model is open economy, but then it doesn't matter because I don't think we have include any two country model. And given that if its model is more economy without the shock, external shock or foreign shock, it is more or less the same to closed economy, which are external shock.
Okay. So because I worry if you have like small open economy and if you add price stickiness, so the monetary policy would be totally different from closed economy model. So that's why if you can ask, for example, like Gali and Monasali, so that would be better. You can see, of course, admittedly, the model complex. It's like medium scale model. Yeah. Okay. So thank you.
Yeah, thank you. We try to do that, but we do find during the during the project is that many models share a large similarity compared to other model. So it's okay to include more model, but we try to keep the analysis small, and given that we have all of that aspect or characteristic inside the set model already also.
Okay. Yeah.
Thank you.
Yeah. Thank you. Yeah.
Thank you, Anne, for your presentation, and thanks, Hai, for questions. I have a question. So in your final slide, Anne, you say carbon pricing informing should be done in advance, so to avoid inflation, right? So carbon tax easy to inform in advance. That's what Singapore, for example, done. They posted what will be carbon tax for many years ahead, I think until 2050 even. Yeah, but for emission trading scheme, right, the carbon pricing is like set by the market, right? It's not known, the price. It's hard to inform because it's like, changes. So what is your like recommendation how to do this informing about this carbon price in advance?
Yeah, of course. Thank you so much. So the paper is focused on really narrative, kind of narrow point of view. Is that the question we answer is how, if we want to achieve environmental target purely through carbon price or carbon tax, what can be the economic effect of this? So the model only answer this question. For your question, it's actually a good question because some carbon trade system is basically based on a market space, and then we cannot impose the high carbon price or carbon tax on this. So I'm not sure I can answer for that cases specifically. But my conjecture is that you can always impose, let's say, the minimum price or carbon price inside the carbon trading system, carbon trade system, so that you indirect increase the level or average level of carbon price in those countries that using market-based carbon price to achieve your target. Did it partly answer the question?
Yeah, thank you very much. Yeah. Any other questions from audience about carbon pricing? So we got speakers from Indonesia just now and Indonesia recently announced carbon tax, right? And going to have ETS. So please, yeah.
Thank you for your presentation. I'm not quite following from the start, but I would like to know about your perspective because we have several type of countries, continent, and so on. And it must be the price supposed to be like different. And what do you think in your personal perspective? Do you think we need like make a committee, the one that who like evaluate or who to, how do you call it? Make a decision. Okay, this country supposed to be CO2 is this price, and this country CO2 must be like this price, like that, or like what? Thank you.
Yeah, thank you. That's a pretty good question. One thing that this paper is not taking into account, but other paper of myself also take this into account, is how large is your green industry. So if the country have the right, you can imagine that if the country that have a big green industry, that's low emission or low emission industry, you don't need to actually increase much of a carbon price. And but for the country that you have like really small green or low emit industry, you have to increase the carbon price or carbon tax a lot to cut out the emission. So the question is really good and highly relevant here. So it's highly depend on the country situation, given the data inside the country. So one way to do it is using the model, so you can predict with a really well calibrated of green versus brown sector. If I can use that wording, you can have a good prediction of how much you need to rise your carbon price to achieve your of course environmental targets. So it's highly related to country specific market structure also.
Thank you very much, Anna. To this, I can add that IMF proposed the minimum floor carbon price and then ask countries to follow it, like because no one can agree to ideal carbon price. There is no ideal carbon price. So then they said, IMF said, okay, if we cannot agree on ideal carbon price, on perfect carbon price, then let's at least agree on the floor, like minimum carbon price that countries should agree on. But that I think haven't been implemented. So what the European Union did instead, they implemented carbon border adjustment mechanism, right? Then now countries thinking, oh, instead of paying to European Union at border, why don't we collect money locally, domestically, right? At least even at low carbon price. So what's happening now, like countries like Kazakhstan, developing countries, carbon price is quite low. And then some people ask me, like, why countries like Kazakhstan, why we have a low carbon price? Then I said, okay, at least they have carbon price, right? Because many countries in Central Asia, Kazakhstan, the only country who got carbon price, right? In Southeast Asia also, it's, I think only Indonesia, right? Yeah, and of course, Japan got, Korea got, China got, yeah. So maybe it's a start and then gradually will increase, right? Because for example, Indonesia, how many times they postponed, right? This carbon tax, because, and Kazakhstan also one time they just shut it down temporarily. Why? Because of all the challenges with implementing this carbon tax. Yeah, so that's very nice Ant's presentation, that he warning policymakers about consequences, and even monetary policy, even central bank need to be worried also and plan, right? This. Yeah, thank you. Another question, please. One more question.
Oh, thank you very much. My name is Juan Gonzalez from Guma University. I'm sorry, I also joined in the middle of the presentation. But when you were talking about like information ahead of the carbon tax, what immediately came to my mind was something like the forecasting prices of electricity markets, right? That you get the information like one day ahead or a few hours ahead. Are you considering the same scale, or are you thinking more of like yearly prices or monthly prices?
In our paper, at least what we talking about re-announcement, or we use a little bit more ambitious like forward guidance carbon price, mean that we want to say that we want to communicate ahead, like at least a year, or at least in this paper is like 4 quarters ahead of a year, 1 year again ahead. In terms of what we're gonna put, which carbon price we're gonna put in the market in 1 year. So you can imagine that 1 year ago, you know exactly that the government gonna put carbon price in this year at this exactly certain amount of level. So you anticipate this carbon price ahead, and then you have some time to prepare or save, increase your saving, or in terms of firm, maybe they invest more into a payment technology to clean up their emission, so that they pay less price for their carbon emission. That's that, at least for what we are doing in this paper.
Thank you very much. So it's 4 p.m. This is time for our final paper, but he's not here yet. I suggest we spend these 5 minutes for questions to any paper, about any paper. So if any questions, speakers also you can ask. And then after 5 minutes, if speaker doesn't join, then we will close, I think. Yeah. So questions about any paper. Yeah. Any raised hands? Okay, please. Thank you. One question from audience.
Thank you for your sharing. I got one question only. So you, like, for your research, I want to ask, have you applied your model in the real world?
The last one, if I know.
Yeah, the last one.
So the real world, that's a good question. Right now, I mean, we don't have anything close that ambitious. So what we show here is really ambitious climate target, like 40% cut immediately in 1 day. That's require a big carbon price increase. So this is at least the paper I want to jump ahead and give some like at least some prediction or conjecture about how the economic cost should be. Of course, we do have carbon price here, and also using some paper on using like Euro area or European carbon price data. They do find some recessionary effect of carbon price in Europe using real data, empirical data. I think no, for me, we don't bring it into the real life, but we do know that some central bank, they actually starting or already enrich their own model to conduct some scenarios similar to us. And in this paper, we're only talking about monetary policy, which is a bit not so effective because we don't really consider also the green and brown economy. In one of the other paper of myself, I do incorporate separately green and brown sector, and then I propose using more like heterogeneous approach policy to target each sector separately and bring out more effect in mitigate the carbon policy risk.
Yes, thank you. So can I interpret your work is based on the results of simulation or monitoring, right?
Yes.
Okay, so I got another question about what kind of factors we may encounter as when we want to make the proper policy in the carbon.
Okay, so so you want to bring you want to determine optimal carbon price, right? For
Like the
or...
factors we may encounter as if we want to apply the carbon policy to the public or the society.
Yeah.
I mean,
so
yeah.
I think I briefly answered one kind of similar, but of course not the same question. So I think one of the big factor that you want to take into consider is the structure of your economy. So whether you have like a big green sector, or in our language, low emit or non-emit sector, and brown sector, which mean like high emit sector. This is highly, and then how the substitution effect between those sectors. So if the two sectors are completely separate and cannot be substituted to each other, then when you bring in the carbon price, maybe the economic effect or economic cost is much higher because you have less substitution effect between one sector to the other. So in my perspective, which is not in this paper, is that it's highly relevant to determine. Also in of course, like in the at least in the field of the model, no one, to the best of my knowledge, no one take into account emission in terms of carbon price. They only take into account the welfare of the household, which in term which most of the model we predict that the carbon price will become a subsidy, which is counterintuitive because we want to reduce emission. So because, and then the household surely doesn't really favor carbon price, given the economic cost of it. So in conclusion, I could say that the factor you want to consider is how big is your green sector versus your brown sector in the country. It should be taken into account seriously.
Okay, thank you very much. And I have a question about the the first paper or second paper, I can't remember specifically. You have mentioned about the first speaker or the second speaker, I can't remember. The energy poverty affects 40.4% population area. This kind of topic. I want to ask for the specific areas in that have been affected by the energy poverty. Thank you. Maybe she's not online. Anna. Okay. Anna. She's not here. Oh, okay. It's okay. It's fine. I mean, the 40.4% of population. So I want to figure out the specific areas that have been affected most severely. Yeah.
Thank you. Very good question. Yeah, this is like shocking, right? Like a big number. But I also worried when I calculated for Kazakhstan and Anna calculated for Kyrgyzstan, and our numbers quite similar. So I think it's probably true. Probably true. So it's big number. And so who are mostly? It's mainly rural. I mean, rural, like villages. Yeah. Why they are? Because they have low income and because they have lack of energy infrastructure. So that's why energy poverty is high in rural. Yeah, also could be some like regions where even like where energy infrastructure is bad, for example, and where like low income or maybe unemployment is high. So could be. So Anna actually showed some regions, but I never been to Kyrgyzstan, so I don't know these regions. Yeah, she put, so I cannot explain your idea. And for Kazakhstan, I didn't look specifically which regions more poor, but we looked at according to gender. It's, I think for gender, when male-headed households, it's increased energy poverty. So like from 49, I think, % of male-headed household, and then education important. So if less educated household head, they are more likely to be energy poor. Yeah. Okay. Thank you. If no questions, I think our speaker haven't joined. So may I confirm Kumiko-san, right? I don't see his name. Nicholas.
No, he hasn't joined.
Okay, thank you so much. So final things, we have one question from the audience. Muhammad, thank you so much for your question. Would the committee share presentation slide and e-certificate? So after this event, around 1 or 2 weeks after, ADBI will post on the event page presentation slides. Yes, and even for people who couldn't join for video presentation, we'll ask them to record video presentation and also put it on the website. So the link you can find in the chat box, which Kumiko-san kindly put in chat box some event links. So you see them after 1 or 2 weeks, you can check. You see it. Okay, and then okay, thank you so much to everyone who joined this event. We had great audience both online and virtually. Sorry, Mohammed, about e-certificate. Yeah, unfortunately, we usually don't provide a certificate for, especially when virtual. Yeah, sorry about that. Okay, so thank you so much for great event, which we had hybrid here in Matsui in Japan and also virtually. Thank you everyone for joining. You are really great audience. We had excellent questions and excellent presentations. I hope this will continue with publications at ADBI and so on. Thank you so much, and please subscribe to our newsletters to join our future events. We'll have some hybrid events in Kazakhstan about energy transition mechanism I mentioned. So it's all on ADBI website. Please follow. Thank you very much.